Hey there, welcome back. This is Module 5, Video 10. In this video, we're going to design and build our parallel action, which is something of a counterpart to the sequence action that we wrote in the last video, where a sequence action runs each child one after the other. A parallel action will run all its children at once. So let's get into it. Okay, so similarly to sequence action, we're going to take um, any number of children, any number of child actions to execute. I think there will be some tricky aspects to the implementation here. For one, duration. What does it even mean to talk about the duration when all children are executing at once? And I believe it will just be the maximum duration of any child. Because they're all executing at once, then obviously the one that takes the longest kind of defines what the duration of the parallel action is. And when we execute, the difficulty is going to be in the execution context, because we won't be able to pass through the execution context to every child, because then we would have a compounding effect on progress, because every child action will kind of add progress to that execution context. They're all going to add together instead of only adding the progress of the longest running child. So we're going to have to do something tricky here and perhaps create a copy of the context to pass through to most children, except for the one that actually, takes the longest. But let's start with the tests, and yeah, let's start with the simple tests around the constructor and the duration. Okay, so making sure we throw, if we pass in null to the constructor, making sure we get a duration of 0 if there are no child actions, and differently to the sequence action, we're making sure that the duration is the maximum duration from all the child actions. So in this case, we've got 4 child actions, and one of them has the longest duration of 5 seconds. So we make sure that the duration of the parallel action is 5 seconds. Because even though it's going to execute all these actions, it's doing so at the same time. So the effective duration is the duration of the longest child. So let's first of all get this building. We need to change our constructor. Okay, now we can try our tests. Okay, so we have the values we expect. So let's implement this. So there we go. The only complexity here is we're selecting the duration of the child and defaulting if it's empty, so that we get 0 duration if there's no children, and then just taking the maximum duration. Let's try the tests. Okay, cool, we're passing. So now for the more difficult part, the execute async. Let's start with some tests here. Alright, so let me walk you through these tests. There's a fair bit going on here over and above what we've done for our sequence action. So first of all, similarly to our sequence action, we do make sure that every child action is executed when we execute the parallel action. So that's an easy test. We also make sure that we can skip over actions that are shorter than the skip ahead. So here we've got a skip ahead of 70 seconds, and so that should skip these two actions, and we verify that down here. And we do the same thing even if the context is paused for the same reasons as we have previously, which is to make sure that when the user returns to an exercise program, the context is kind of moved forward to the point where they left off. Now we've got something unique to the parallel action here, which I mentioned before, is we need to make sure that the durations of the child actions do not compound in the context. So we've got 4 child actions here. Each of them takes up a certain amount of time, 1 second, 1 second, 2 seconds, 1 second. And when they execute, they add that progress onto the execution context, which actions will do once we get down to actions that actually do something specific, like waiting. Those actions will need to add progress onto the execution context. So we're kind of simulating that here by each action adds its duration onto the execution context and then just returns that it's done. And what we want to make sure of here is that once we've executed the parallel action, the progress in this context that we're passing in is only 2 seconds, because that's the maximum duration of any of our child actions. We would not want to see 5 seconds, because that would be the sum of all these child durations. So that's one important test, and we do the same thing when we're skipping, because we're going to have some specific logic around skipping. We're going to have to find all child actions that are skippable and skip them, and then all other actions that are longer than that will need to be executed. So for example, here we've got 4 actions, one at 3 seconds, one at 8, one at 10, and one at 4. So if we're skipping past the first 5 seconds of the parallel action, that means it's going to skip this action because it's only 4 seconds, and this action because it's only 3, but these 2 actions should still execute. So we're executing the parallel action. We make sure that our progress is only 4, even though we've asked it to skip 5. It's only going to be able to skip 4 because that's the maximum duration that is less than the skip ahead that we're passing in. And then we verify that action 1 and 4 were not actually executed. Now, cancellation and pausing of the execution context is interesting because, as I discussed before, we're going to have to pass in a different execution context to all bar one action. So the one action that we care about really is the longest one. It's just kind of a special one in the sense that it's the one that we want to get the real execution context, and other actions will get some kind of shadow copy of that execution context. So these tests are basically making sure that we shadow it correctly. So if you cancel the shadowed execution context, that will propagate through to the real execution context, which is this one that we're passing in. So we've got 2 actions. One is 13 seconds, the second one is 8. And when the first one executes, it cancels the execution context. So we execute the parallel action, and then we make sure that the context is cancelled. Now there's no reason why this one shouldn't work, because the action doing the cancellation here is the longest running action. So it should, when we get to the implementation, I expect that action will get the real execution context, which is this one here. So there's no reason why this should fail, but it's a good backup test to this one, which is where we swap the lengths around of the actions. So the first one's a shorter one, the second one's a longer one. So we would expect this first action to get some kind of shadow copy of the execution context, so that when it cancels it, it's actually cancelling on the shadow, not this one. So we need to make sure that despite that, we still get this propagation of is cancelled through to the real context. And then these last two tests are exactly the same thing, but for pausing the execution context as well. Alright, so let's try running them. And we've got build error here. Oh, I forgot to rename this test. Can be paused. Okay, so we are failing on all those tests and in the expected way. So let's think about an implementation here. God, I can't believe I've forgotten that same test once again. Happens every time. The simple test, which is to make sure that we throw if the passed in context is null. Here we go. So first of all, let's assert this is not null. And let's just take a moment here to think about what it is we need to do here. First of all, in order to facilitate skipping ahead, we have to kind of segregate our child actions into two groups. One group that are less than or have a duration less than the skip ahead, and the other group which do not. So the first group we would skip over and the second group we would execute. Once we've determined that, if there are any children that we need to skip, then we need to add progress to the context, but we need to make sure that we only add the progress of the longest running skipped child. Because if we're skipping two children, one's 4 seconds, one's 2 seconds, we want to make sure that we're only adding on 4 seconds to the execution context progress, because remember we're running in parallel, and this, we just saw this in the test, one of the tests before that we're checking for this. So that kind of implies we need to group the children and we need to sort the children by their progress, by their duration. And then as for the children to execute, assuming there are some, for each child that is not the longest running child, we'll need to create some kind of shadowed execution context based on the real execution context. And we need to execute all those children with the shadow, and then we'll need to execute the longest running child with the real context. And then we need to kind of await for all those child tasks to finish. So there's a fair bit going on here. Let's start with the link logic to kind of group and sort these child actions. Okay, so just to explain, we're taking all the children, ordering them in descending order by duration first, and then we're grouping by. You've seen this expression before in the other actions and exercise program, etc. Basically, making sure we do have some skip ahead, and if we do, and it's longer than the duration of the task of the action, sorry, then that gets grouped into the first lot of children, where this expression will be true, and otherwise it gets grouped into the second lot of children, in which case this expression is false. Now the first group where this is true means we're skipping them, and the second group where this is false means we're executing them, which is what I've kind of extracted here. So taking that expression here, which I've converted to a list by the way, so we just evaluate that once and be done with it. And then I'm finding the single result where the key is true, which means we're skipping them, or a default, which means that will be null. And similarly, to find the ones that the children that we're going to execute, we find the key that's false. So now we can do something with this. We can do the skip ahead logic like something like this. So because we've ordered the children in descending order of duration, we know that the first child in each of these enumerables here, which I may actually convert to a list as well, I'll have a think about that. We know that the first child is the longest running child. So all we're doing here is saying if there are children to skip, then we know that the first one in that enumerable is the one with the longest duration. So we extract that duration and we add that to the context. It doesn't matter how many other children we're skipping because they're all their kind of execution is all encapsulated in the progress of the first one because we're running in parallel. So now we can move on to the execution logic. Okay, so basically the idea here is we create this shadow execution context, which I have not done yet. We'll get to that in a sec. And we base that on the real context. And then we take the first child, because we know that's the longest running child. We want that to be our kind of primary child that gets the real execution context. So we select this execution task from that child, and we convert it to a list, even though we know there's only one item in that list. That makes the latter logic easier. And then we've got subsequent child executions. So we skip the first child and then we do the same thing, except this time we're passing in the shadowed context to each of those child execute async calls, and we're converting that to a list. So we've got two lists of tasks. The first list will always have one item in it, which is the primary child, if I can call it that, that's getting the real execution context. And then the second list contains the task for each other child action that gets executed. And if there's only one child in the parallel action, then this will be an empty list. Okay, and then we're taking all those tasks, we're concatenating them together, which is what I was referring to as being made easier by using tolist, because concat needs enumerables. And then we're awaiting all those tasks, and then we've got our familiar continue on any context here. So that, I think, is the required execution logic, but now we need this create shadow execution context helper method. So I'll create that down here. Okay, so here's what I'm thinking should work. First of all, we create another execution context, which is our shadow execution context, and we pass in any skip ahead from the original. And then we copy across a bunch of information, the current exercise, the current set, the current repetition. That's all simple to copy across into the shadow. And then the more tricky part is we kind of monitor the is cancel property on both contexts, and we propagate any changes, so any changes to true, that is, to the other context. And similarly for pausing, although a little bit different, we monitor the is paused, and whenever that changes, whether it's true or false, we update the other context with that same value. So hopefully that's sufficient to get us up and running here. Let me try the tests. I've got some build errors here. I think for some reason Xamarin has been a real pain in the butt today. It's not resolving stuff for me, so I think it just wants system reactive link here. Let's try that. One error because I'm not returning the the shadow execution context here. Okay, so it seems like we've got an issue with our tests, one of our tests, because it's just hanging. So let's have a look into that. I'm just trying to figure out which test it is. If that one's passed, unfortunately it doesn't tell you which test it's about to run. So I might just run through them individually. Okay, so here's one issue. Execute async ensures progress of child actions does not compound when skipping. That is failing. So it's getting 14 even though we expect 4. So we expect the context progress to be 4, and it's 14. That's because we've executed. Which is interesting, because that's still an issue, I believe. You know what, I think the logic here is wrong. This is entirely unnecessary, I think, because we're still going to execute the primary child unless there's no children to execute. This is interesting. Well, except that should never happen, right? Because if there were no children to execute, that implies that the skip ahead is greater than our duration, as in the duration of the parallel action, in which case nothing should ever have called execute async against this action. It's a little bit of an assumption, and maybe it needs to be manifested as a debug assertion here. But I think essentially what we're saying is this does not need to happen because we're always going to have at least one child to execute. That is the assertion that we should make. And consequently, we can assume that this is non-null. And so essentially the children to skip, we're just kind of ignoring them. We don't even need this. We can just comment it out for now. And that should solve that issue with that test, I think. Although it's still going to fail because we're checking the progress incorrectly because we still executed the action. But let's just make sure it fails the way we expect it to fail now. Does not compound. It does work now. Why does that work? Oh, when skipping. Okay, yeah. So we expected 4, but really we should be expecting 10, and we should come up with some other way to make sure. No, that's fine. We should change that to 10. That should be exactly the same assertion. although we changed the numbers here, that's why it's not going to be exactly the same. But the point is, 10 is the lengthiest action. So even though we're skipping ahead, even though more than one action is actually executing, we still expect the context to only kind of progress by 10 seconds because all these actions are running in parallel. So that makes sense. Let's move on to other problematic tests. Okay, so a verification exception in executes each child action. Really? That's unexpected. That is most unexpected. Let's debug through that one, because that makes no sense to me. Alright, so children to execute. I should have changed that to a list. So the key here is false, which means I should be executing. Children to execute is not null. First child execution, and subsequent child executions. So this looks like it's doing the right thing. So which one of these is actually failing? 2. Just to make this a bit easier to debug, I'm going to convert this to a list. And these are already lists. Okay, so it has all 4 children identified as executable, so that much is correct. Unfortunately, it's a little bit difficult to identify them. Maybe I should give them some durations. But this should be 1 task, which it is. This should be 3, which it is. And then we're concatenating them together and waiting for all of them. So yeah, I'm really confused as to what's going on here. So I'm going to pause and look into this deeper, and I will resume the video once I've figured it out. So some of you were probably screaming at your screen as I was fumbling about here, but you probably knew the problem here is these verifications are against the real context rather than the shadow context. So actually, we don't care which context we get here. So I'm just going to change this to is any execution context. And I wonder whether I've got this problem further down in other tests as well. That one should be fine. I almost think, why am I bothering to verify against a specific context? Because it doesn't really matter from the perspective of the correctness of these tests. So let's change that and that. Alright, let's try that test again. Oops. Okay, so now it's working fine. Let's continue on here. That one's working, that one's working. Okay, this one is the one that's blocking. Execute async throws if the execution context is null. Wow. That's another unexpected. Oh. Sorry, I'm just not switched on today. It is Friday, in my defense. Hooray! Everything's passing. And I'm reasonably happy with the quality of these tests. although I definitely think they can be improved, and stuff like this does concern me a little bit because there's nothing stopping someone from passing in, from attempting to execute despite there being no children to execute. So it's a little bit iffy, but I'm going to leave it as it is for the purposes of this video. And I think this is probably the most complicated action we'll have, but we'll see. So thanks for watching, and sorry for the fumbling about, but it is what it is, and I will see you in the next video. Cheers.